Hello everyone, my name is Chen Yizhu. Today I'm going to present the article Erosion in Buenos Aires Province, Coastal Management Policy Revisit. The reason I choose this paper is that in this reading, they show a basic method to estimate the erosion rate of coastal area and also provide a detailed research result. And this not only enable me to have a better understanding on the actual operation of this kind of research, but also brings me a basic knowledge about the coastal area of Buenos Aires. So let's start my presentation. I will separate my speech into 5 parts: introduction, study area, methods, results, and conclusions. Let's start from the introduction. The background of this article is that Buenos Aires province in coastline is dominated by a longshore transport from south to north. Obstruction performed at the beginning of the 20th century originated with reduction of some beaches. The objective of these researchers is to analyze the success of coastal defenses and simulate future position of the coastline for the next 20 to 30 years. Study area. As you can see in the figure, the research team investigated the east coast of Argentina here and from the north of La Costa country to the south of Patagonia, and I will explain the detailed results later. Here are different methods that the researchers estimate the coastal erosion rate in their study area. Coastal erosion rates between 1957 and 2009 were estimated based on different remote sensing techniques. Beach balance has already been reported in previous contributions based on periodic topographic surveys. The source of data used to determine coastline change were estimated from vertical aerial photographs from different years: 1957, 1967, 1970, 1975, 1984, 1985, and 1989. Photographs from the Corona H4 satellite were also handled. After 2009, the source corresponds to QuickBird satellite images from the Google Earth. The resolution is about 2.5 meters spatial resolution. The aerial photographs were digitized with a high-resolution scanner, which is 1200 dpi, and referenced with a minimum of 15 control points in the metric Gauss-Kruger projection system. Based on these estimations of coastline retreat, the forecast coastline position was simulated for the next 20 or 30 years, applying a Oikos Leonardo da Vinci simulation procedure. This program runs simulating the advance or retreat of present coast considering major or estimate average rates. Coastal erosion risks were analyzed considering the hazard and the vulnerability component of risk, R equals to H times V. The methods were in accordance with modern procedures. The hazard index is compounded by 9 indicators, each rescaled between 1 to 5. Storm effect, maximum tidal range, mean wave breaker height, type of wave breaker, beach mean grain size, beach width, foreshore slope, coastal geomorphology, coastal erosion or advance rates. The vulnerability index Also, the scale between 1 to 5 was calculated considering demography, living condition, job and consumption indicators. They include population census data, education, health, sanitary, economic, production, and work and population exposure aspects. So now we understand the method to determine the coastal erosion and the erosion risk. Let's see the result of their investigation. Let's look at long-term erosion rate and vulnerability. The coast of Buenos Aires is dominated by low to moderate erosion trend. Very low rates were recorded in areas related to Colorado River Delta. High rates are located at General Prison and Partido de la Costa. Erosion rates over 1.3 meters per year were estimated at the southern coast of Machakita. Coastal accumulation were only recorded at the south of Partido de la Costa, northern San Antonio Cap. The hazard index is very high in areas subject to drift obstruction, such as Nicosia and Machiquita departments. Here, these coasts are characterized by low altitude cliff or receding fault dunes, and subject to frequent storms from the southeast. The Partido de la Costa, General Prison, and General Alvarado counties present a high hazard due to high value in erosion rates, storm effect, and beach wave indicators. Moderate hazard index correspond to non-urbanized area. Regarding risk analysis, a high value corresponds to the touristic coast of Buenos Aires province. There are localized areas of high risk concentrated at the southeast region, subject to impact of recurrent storm. After applying the methods that I have mentioned before, the researchers' team conclude the accumulation and erosion rate of their study area. In this figure, they show the coastal variation along the eastern barrier of Buenos Aires. So you can see here is the erosion rate and the accumulation rate. And this figure shows the variation in the erosion rates at the southeastern region of Buenos Aires, a coastal dominated by artificial structures. In General Prison, Mar del Plata City is where erosion has been more intense. 3 beaches were artificially nourished, and several growing field and rubble mound structures were constructed. The erosion process of the embayment of Miramar City increased due to the forestation of a dune field that had been supplied sand from the south. And about the erosion rate along the southern barrier of Buenos Aires. The erosion rates are higher to the east due to the effect of the Neochia port. Here, obstruction and a modern prolongation of the western jetty. One of the crucial processes of this course is the deactivation of sand ramps, sand cleavage to form a cliff, remaining as cliff-top dunes. And now let's look at the recent coastal engineering improvement, the detached breakwaters project of Los Acantilados. The picture start from 1997, 2004, 2011, and 2012. About these breakwaters, 8 detached breakwaters were proposed in 2008, and in 2012, the third breakwaters were not detached from the coast. And here is another coastal engineering improvement of Argentina. The stability of the sewage disposal outflow. To fix the stability of the outflow pipeline in cement, two jetties were constructed. For many years, Madepala City has a sewage network discharging at the northern coast in cement. The outflow was located at the beach. The growth of the city was progressively conditioning the bathing quality of the northern beaches, and a 3,500-meter pipeline with diffuser at the extreme was originally projected to operate at 12-meter depth. A sewage outflow was definitely installed at the beginning of 2016, and since then it has been operating properly. In previous two example is about the authorized construction, which is built by the government. And now I will show the example which is non-authorized. This is the non-authorized drawings. Non-authorized drawings were constructed at Punta Central and later destroyed by the demand of Buenos Aires authorities. In Punta Central, during the end of the 90s, a private company, restaurant with seaside facilities, constructed two drawings, taking advantage of quad-sized block from the surroundings, and without consulting with the government authorities, although the law precisely states that only the province has jurisdiction at the coastline. So, after a series of discussion between the private company and the government authorities, with a certain delay, the owner of these facilities were demanded to destroy both drawings. Finally, about 2014, Punta Central was modified into its natural conditions. And here is another example about non-authorized drawings. At the coast of Estancia San Manuel, 1 kilometer north of Samet Norte, the owner of the land constructed a shore drawings without the necessary permission of the Buenos Aires authorities. As you can see in the figure, the drawing is still there. And about the discussion, in Latin America, coastal erosion is not considered a serious threat. In Colombia, the hard defense policy has been applied along the sun and beach touristic coastline. However, most of those structures were apprehended based on empirical experiments. Coastal retreat rate of 21 meters per year were estimated. One significant problem is the competency of streets in situations on the subject. On the other hand, at some portion of this shoreline, there is no authority responsible for the environmental impact assessment requirement. Close to 90% of the house structures constructed failed in their purpose. Negative consequences were estimated in 85% at the downstream side of drawings. Regarding global changes and their indirect coastal impact, such as the increment in storm and flood frequencies, it is recommended to avoid traditional cost-benefit analysis, and the holistic analysis should investigate the consequence of these changes in the touristic economic and non-market effect upon the environment. And now we are at the end of the article. A conclusion. First is In the sandy coast of Buenos Aires, there is a storm-triggered erosion problem that increased, where man activities are inducing sand imbalances. Second, new strategies to prevent drift obstruction should be planned, but based on a scientific-based knowledge of the nearshore dynamics and validated by models. And that's all my presentation. Thank you, Professor.